So hey guys, it's me Dawson from Decoders. So in this I'll be talking about the Arduino introduction and programming. So before I start, I would like to make a disclosure that this PPT has been taken from the internet. It has been prepared by Anurag Dwivedi and Rudra Pratap Suman. So a huge shout out to them for the PPT. Hey guys, it's me Dawson from Decoders. So in this session I'll be talking about Arduino, its introduction and programming part of it. So what is an Arduino, you might ask? So Arduino is an open source electronic prototyping platform based on a flexible, easy to use hardware and software. So it is kind of a microcontroller board which you can use to do electronic projects. So uses of Arduino are as follows. So boards aren't just boring. So what can Arduino do is you can use to do robotic stuff. Robotics in the sense you can make automatic sensors, and you can combine sensors, and you can do all kinds of crazy cool electronic stuff. You can even use audio also using some modules. You can connect audio. You can even do IoT also, that is Internet of Things. You can connect you can use some modules such as Node MCU, and you can connect it via Internet of Things, and you can do crazy amount of stuff like Wi-Fi enabled home automation system and all those things. Then you can even do tools also, various kind of tools and all those stuff. And you can even do data logging also, like in library when you enter, a log will be there, like that you can do logging. And you can even do networking also. You can create some home like local network, local RFID networks and all those stuff. And then it is even used in a medical also, medical field, to create to generate medical data and all those stuff. So getting started with programming. So the bare minimum code is as follows. There is void setup. So what happens is there will be a Arduino IDE. There you can type and you can do programming. Let me type Arduino. So this is the app actually. In this app, so guys, just bear for a few minutes. This Arduino IDE is loading up. It's been a while since I have opened this IDE. I still remember in 9th standard I wanted to, in 9th standard I ordered Arduino board and I was doing some programming. So this is the board actually. So this is the user interface. This is the IDE. Here you can do the programming stuff. So you can see there is void setup here, and you can see there is void loop here. So this is the way by which the system works. There is void setup and there is void loop. Void setup in the sense you can put your setup code here to run once. It runs only once, the void setup thing. Void loop thing, what it does is it runs it up automatically again and again and again and again. So you can easily do so for the initialization part you can keep it inside the void setup, while for the looping part you can keep it under void loop. So setup, okay, setup as usual, what I said, it is called when the Arduino is powered on or reset. It is used to initialize variables and pin modules. So loop is the loop function continuously runs continuously till the device is powered off. So the main logic of the code goes similar like this, similar to while one for microcontroller programming. So it's kind of a while loop. It keeps on going again and again and again unless and until it gets stopped. So pin mode is there. So a pin on an Arduino can be set up as an input or an output using a pin mode function. So pin mode function is there, that is you can set up the pin, that is I'll be showing you now, just now in a few minutes I'll be turning on my camera and I'll be showing you the board. But the thing is there is something called as a pin mode which you can use. So pin mode 13 output, the output is it suggests that the pin 13 is used as an output pin, that is you can connect the pin 13 to a LED and you can expect the output to be generated. Next is pin mode 13 input. You can type pin mode input in the sense you can take input data such as in this thing, what do we say, in this thing, in any kind of any kind of an input device, such as you can take an example of IR, that is infrared sensor. In that also you can take it as input, so that port is used as an input mode. So reading and writing as follows. You can use digital write, you can use digital write, that is pin 13, you can set it to low, so it makes the output voltage on the pin 13 on 0 volt. Then digital write 13 high is there. So what happens is here it makes the output voltage on the pin 13 5 volt. So there is low and high. This is called as digital signal, zeros and ones. So next is button state. There is button state digital read 2. So digital read 2, what it does is it reads the digital signal on the 2, and it sets the value to that variable, that is button state input. So next, what is an analog signal, you might ask. Analog is a continuous range of voltage values, not just 0 or 5 volt. That is analog, it consists of too many values. It's kind of an analog kind of a thing. There is a digital watch and analog watch, right? So like that. Why convert to digital? Because your microcontroller only understands digital. So a microcontroller only understands digital, so you need to convert it. So analog to digital converters convert analog signals into digital signals. So the ADC in Arduino Uno. So this is the Arduino Uno board. Here, let me just take some marker actually. So you can see the model made also. Okay, so this thing model, it can be made in any countries. So since it's open source, and there is yeah, this board. This point I do not know. This is the ground pin. This is the pin 13, pin 12, pin 11, pin 10, pin 9, pin 8. This is called as the digital. These are all the digital parts, zeros and ones. Yeah, 0 and 1. Then next there is TX and RX. TX stands for transmission, it stands for, RX for input. So these two pins can be used to connect via another device also. So these are all digital signals, and this symbol stands for PWM. PWM stands for pulse width modulation. That is, it's kind of an analog kind of a signal, but it uses digital signals to convert it into analog. So this part of the board is there. So you can see there is a one is in pin 3, another one is in pin 5, another one is pin 9, another one is in pin 10, another one is in pin 11. So these are all PWM signals. So this, you can see there is a crystal oscilloscope also. So sorry, there is a crystal not oscilloscope, this is called as a crystal oscillator, I think crystal oscillator, 16 megahertz I feel it is. Then there is this thing, that is this thing is the port actually. This port, you can connect it to a cable, special cable, and you can connect it to your computer. So next part is here, there is a lot of ICs, and you can all see, and there is something called as an L, and there is also called as TX and RX. TX stands for transmission, RX stands for receiving, and there is this symbol, this, when it turns on, this thing flashes, and this is the light, this is the by default pin. I think the default pin is 13 or 12, I'm not sure which pin it is, but by default, if you want to just check whether the transmission is working, this is one default pin. And here there is a reset button. Reset button, when you press, what happens is the board gets resetted and everything starts. It goes to void setup, and then it goes to void loop. So next there is analog in. Analog in stands for analog signals, that is 0 to 5, and any one value it comes, and it keeps on increasing. So there is analog A1, A2, A3, A4, A5 is there. Next is power is there. Power, there is voltage in, that is positive. Then there is ground, which is negative. So these two parts you can connect. First, after programming, you can flash it to your board, and after that you can keep these two running on your this thing, that is in your battery, and you can keep on running this board. Then you can use 3.3 volt, and you can even use reset pin also. So here there is this is the bootloader of this thing. Yeah, bootloader I feel. Yeah, this is the bootloader. It's Atmel I feel. Yeah, Atmel 1015 it is. So this is the main chip by which it gets powered. This chip also, you can don't need to create this Arduino board only. If you are having this chip, and if you are having some soldering equipments at home, you can do this board on your own only. So it's kind of an open source kind of a board. So converting analog value to digital value, you can see the input voltage here. 0, it's analog to input voltage. Just a second. Yeah, analog to input voltage, it comes to 0. 2.5, it comes to 127, and 5 volt, it comes to 225. So 255. So that is the converting of an analog signal to digital signal. So you can see the quantanization of it. So what had happens is it divides it into levels. That is, there will be a signal, that is volt from 0 to 5 volt will be there, and there will be a sampling speed, that is the time will be there. So what happens is, when the graph is drawn, graph is drawn, it takes the points in particular sampling period. In between these periods, it takes the points and it converts it into a signal. That is this is the analog signal, this is the quantized signal, and this is the sampling point. So you can see in the sampling points it gets intersected and it creates the signal. It creates the quantanization of the signal. So ADC, that stands for Android to analog to just a second. ADC, I'll come back to it. So the Arduino board contains 6 pins for ADC. We can check the 6 pins for ADC, to be honest. I'll get back to ADC on what it is. I might leave a comment on that, on what is ADC. Yeah, and sorry, ADC stands for analog to digital converter. Yeah, so it contains 6 pins for ADC. So 10-bit analog to digital converter. So this means that it will map input voltages between 0 and 5 volts into integer values between 1 to 1223. That stands for 1 byte actually. One byte consists of 1024 bits. So from 0 to 123 it can come. Next is reading and writing of analog values. That is analog read 0. It is used to read the analog values from pin A0. Analog write 2, 128. It stands for it writes this analog signal to pin 2. So there is ADC example also. You can see the code here. Here they have started the serial monitor, and here it's grabbing the sensor value, and here it's grabbing the output value. Here it's taking the analog write, and here its sensor is equal to sensor value, then output is equal to output value, and after that last there will be delay. So okay guys, thank you very much guys. Feel free to like, share, subscribe, do whatever, but as usual, one thing I'd like to say is never stop learning. Thank you very much guys. And if anybody is interested, I can provide a tuition on Arduino. So if anybody is interested, feel free to click on the link below in the description for the tuition class if anybody is interested. Thank you very much guys.